now my great pleasure to announce this second late-breaking news session of the CSIEC, which is titled Unveiling of a New Cosmic Vision from Euclid. This exciting session will focus on the Euclid mission, a groundbreaking endeavor to uncover the mysteries of dark matter and dark energy, which together make up 95% of the universe. Today, we will unveil a completely new view of the universe, captured by Euclid during its first year, offering a preview of the mission's scientific potential. And please, following this late-breaking news, don't leave. There will be a highlight lecture following under the title Euclid Mission Unveiling the Universe, where we will review the mission's milestones and the first scientific results. But now, without further ado, it is my great pleasure to welcome on stage the Director General of the European Space Agency, Josef Aschbacher, for some opening remarks. Josef, please.
So thank you, Christian, and very warm welcome to this late news story which we have together with my Director for Science, Carol Mandel. But she will then really unveil the secrets and reveal the news. But I show a couple of slides beforehand to introduce the topic and lead you towards the tension and make sure that you are staying excited when Carol will show the first images. So what we see, and this is the next slide, is really that Euclid is something that is addressing something very fundamental for humankind. The quest to answer some of the very fundamental questions about our cosmos and is what makes us all very human. And it drives the progress of science and the development of powerful, far-reaching new technologies. You and me, everything what we can touch and smell, and all the planets, moons and stars are made of what we call normal matter. However, ESA's Planck satellite already showed that normal matter is only a very small fraction of our universe. The remaining 95% of our universe is what we call dark matter and dark energy. This makes galaxies spin faster than we expect, and it makes drive the accelerated expansion of the universe, but they are only invisible to us. In the next slide, we see that ESA's Euclid mission was invented to solve the mystery of the dark universe. It was launched, as you all know, last year in July 2023, and over the next 6 years, we will observe billions of galaxies out of 10 billion light years to create the largest, most accurate 3D map of the universe. This mission has 3 very special capabilities. Euclid can detect very faint light. Euclid can photograph large areas of the sky in one shot. And Euclid has crystal clear vision, and you will see this demonstrated in the slides of Carol. The next slide, to give you an idea of the sensitivity of the telescope. Back in March this year, a few nanometers of ice, the width of a large molecule, had been accumulating on the mission's optics, causing a drop in the light coming in from the distant galaxies. And this was a major issue for us and for astronomers. The ESA teams across Europe work closely with the Euclid Consortium and industrial partners to come up with a precise decontamination procedure that cleared Euclid's vision, allowing it to clearly see faint light from distant galaxies and start the main science phase of the mission without any trouble. And I really want to say, and I say this as Director General of the European Space Agency, that the teams, my own team of ESA, but also industry, have done an incredible job to restore the sharp vision of Euclid. Big thank you from my side to this excellent work. So Euclid is made of a very unique material called silicon carbide, which makes space telescopes robust, but also thermically stable despite the extreme conditions in outer space. And this revolutionary industry is led by the European Space Agency and Europe, and it is part of a remarkable technological advancement that space sciences bring to society. In the next slide, in November 2023, we released the first glimpse of the power of Euclid. And I remember when I was showing the very first image to decision makers, ministers of ESA member states at the Space Council in Sevilla, there was a very quiet period in the room. Everyone was surprised and amazed by the very first image. This incredible snapshot showed 1,000 galaxies belonging to the Perseus cluster and more than 100,000 additional galaxies further away in the background, each containing hundreds of billions of stars. In the next slide, in March 2024, so only this year at the Space Summit in Brussels, we welcomed the mission's early image release and the first 10 science papers in this razor-sharp view of galaxy cluster Abell 2390. We saw detailed structure of giant arcs caused by the bending of light around massive invisible dark matter structures. Although we were stunned by these incredible views, they are but a tiny piece of that Euclid's capability. Today, we release a new milestone, and I invite my Director of Science, Professor Carol Mandel, to tell us much more. Thank you so much.
Ladies and gentlemen, distinguished guests, it is a huge honor to share with you tonight the next milestone in the Euclid Space Science program. Joseph has given you an incredible view of what we did with less than 1 day of observations during the test campaign when we were commissioning the telescope after launch. I want to give you a sense of the scale because it is almost impossible to convey to you what Euclid will do in the next 6 years. This is a photograph from the Hubble Space Telescope. This was 2 weeks of observations that scientists around the world used to study the early universe. As Joseph said, Euclid has 3 special properties, and the first one is the area across the sky that it can image in one shot. And that wonderful Hubble Space Telescope image now is tiny compared to the size of the full moon. A single field, single shot with Euclid gives us 2.5 times the area of the full moon. And to look at one of those images that Joseph showed at full native resolution, you would need 64 4K by 4K high-resolution TV screens just for one image. Now, please keep that image number in your mind. Tonight, we release a mosaic of 260 observations made over the time of 2 weeks in April. This represents only 1% of the Euclid survey. And in order to fully appreciate the image that we released tonight, you would need 16,640 high-definition TV screens. Now, I asked the organizers if we could have 16,500 TV screens tonight, and unfortunately, they weren't able quite to provide 16,500 TV screens, understandably, but tonight we have this wonderful view. So that single image field that Joseph showed is now here. And I want you to appreciate this image. And remember, this is 1% of the entire survey, which will take place over the next 6 years. The blue wispy light is actually dust and gas in our own Milky Way galaxy. And in this image, you'll remember that Joseph talked about 100,000 galaxies in the image that we released earlier this year. There are now 14 million galaxies in this mosaic image, 100 million sources altogether, 14 million galaxies that our cosmologists can start to use to study dark matter and dark energy. And by the end of this survey, there will be 8 billion galaxies that they will be studying. The scale is utterly incomprehensible. And I now would like to share with you a zoomed movie to take you a journey into the cosmos. Thank you. And I take that applause to our teams in ESA, to the ESA Science Consortium, to our teams in industry, to all of the incredible teams that have worked to make this mission possible, and of course our partners who helped us launch this mission. We have optical detectors, as Joseph mentioned. We have an infrared detector. Not only do we take photographs of the sky, we also measure spectra, which tells us the distance and the motion of these objects. And we will make a 3D map of the universe back to 10 billion years of cosmic history. You saw some incredible things in that very beautiful image, and I didn't want to speak and destroy the magic, because indeed magic coming from science and technology, it feels like. But you saw so much physics in these images, and that's the thing about this kind of mission. It gives you the beauty, but we're testing the fundamental laws of physics at the extreme scales in the cosmos. And these are just a few examples that we've pulled out to illustrate what is in the depths of these images. Galaxies that when they get close to one another, the force of gravity rips stars from them. Galaxies that have supermassive black holes at their heart, that when they collide, they will produce ripples in the fabric of space-time, that we will use our LISA interferometer in the future, that ESA is building at the moment for mankind to study the nature of space-time. And all of that will be a legacy from Euclid once Euclid has delivered its science. And not only today are the cosmologists now ready and able to begin to do their work, but we are also transforming the nature of astrophysics itself. No longer can astrophysicists like myself look at an image and do some science on it. In order to remove the very faint artifacts that come from the odd photon of light bouncing about inside the camera, our scientists use machine learning and artificial intelligence algorithms to remove over 100,000 very faint ghost features in here. We have the crystal clear vision of Euclid to see through the dust filaments in our Milky Way. And of course, our Milky Way galaxy has already been mapped by our ESA Gaia satellite. And we bring all of this together tonight to share with you, to show that the new milestone, to demonstrate that we can now do the cosmology, which is the core purpose of Euclid, as well as so much more. And Euclid is an autonomous survey telescope, so we don't decide each day where it should point. Again, clever algorithms as it starts to survey the sky. We've now completed 12% of the survey. We will do the remaining 36% of the sky in the coming 6 years, and we will have our first year of data release in the spring of 2025. I cannot stress the amount of collaboration and friendship that is required to overcome the challenges to deliver such an iconic space mission. You see some of the numbers on the screen here. Credible value for money to our European taxpayers. 2,500 scientists working together over 15 years to make this a reality. Over 2,000 industrial personnel. And of course, our friends and collaborators at NASA, with whom we've worked closely on this mission as well. Ultimately, 170 petabytes of data will be gathered and analyzed and ultimately shared with the world. And it's now my immense pleasure to hand over to Dr. Valeria Petrino, who is our ESA Euclid project scientist, and she will lead the keynote lecture tonight, along with our scientists who are representing the Euclid Science Consortium. And I thank you for your attention and wish you many hours of browsing these beautiful, iconic images of our cosmos. Thank you.